Hello everyone, in this video we are going to talk about how to name our carboxylic acid derivatives. The first one we are going to look at here is acid chloride. So we are going to look at a few scenarios. The first scenario is when we have acyclic acid chloride, and this will be based on the acyclic carboxylic acid. So this is our carboxylic acid, and we know that we are going to call it butanoic acid. So now what we are going to do is, for the acid chloride, we are going to change this IC to YL and then add chloride. So for this example, what we are going to have now is butanoyl chloride. So that is how we name the acyclic acid chloride. The second example is to look at when you have the cyclohexyl group, for example. Then we are going to look at how to name this. This is our carboxylic acid, and for this type, we are going to name it as cyclohexane, and then we are just going to call it out carboxylic acid. This is when your carboxylic acid group is on the ring. So now what we are going to do is we are going to change this XYLIC acid to NYL and chloride. So what that means is, when you have this as a acid chloride, this molecule will become called cyclohexane carbonyl chloride. So that is how we name acid chloride. So now we change it in NYL. And also we know some common names for the carboxylic acid. For example, we have acetic acid. So this is called acetic acid. Now we are going to follow the same rule that we are going to change it to YL. So if you have something look like this, then we are going to call it acetyl chloride. And by the way, this group right here, if we look at this group as a functional group, it's called acetyl groups. So that is acetyl chloride. The next group of the carboxylic acid derivatives we want to name is our acid anhydride. And we have two different types. The first type is when we have a so-called symmetric acid anhydride, meaning the two R group are the same. For example, what we have here is this molecule. This is our symmetric acid anhydride. So what we are going to figure out is what acid it is come from. So we're going to look at this part right here, and we're going to write out original carboxylic acid. So what we have here is propanoic acid as a systematic naming. So then what we are going to do is we are going to change the acid to anhydride. Why? Because it is 2-propanoic acid dehydrate to form the acid anhydride. So the example name here will be called propanoic anhydride. So this is when these two R groups are the same. The next what we are going to look at is when the R groups are different. In other words, this will become a asymmetric acid anhydride. For example, we are going to draw out a asymmetric one on one side. What we have is 4 carbon chain. The other side we are going to put a phenyl group, the ring right here. So now we are going to look at what carboxylic acid is come from. So the first carboxylic acid it come from is the left one, that we have this 5 carbon carboxylic acid, so we call it pentanoic acid. And on the one on the right, what we have is our benzoic acid. So this is our benzoic acid. Now we are going to get these two information together. We are going to follow the general rule to show what is those two R group. So the first one is benzoic. We are going to follow the alphabetical order. So we have benzoic, and then pentanoic, anhydride. So basically, you're telling the audience like what carboxylic acid this anhydride come from, and in alphabetical order. So that is when these acid anhydride are acyclic, so kind of linear. Now we are going to look at how to name a cyclic anhydride. And when you have cyclic anhydrides that form from dioic acid, for example, what we can have is this dioic acid with 3 carbons. We call it O-my. So my is malonic acid. So this is malonic acid. So when it forms the cyclic anhydride, so the reaction is one of the O will attack. Okay, I'm not going to draw out the full reaction mechanism, but what's going to happen here is you are going to form a 4-member ring. So that ring includes this oxygen and then these 3 carbons, and this OH group will eventually left. So the end product right here, that cyclic anhydride, will look like this. You are going to have a 4-member ring. And next to this oxygen, you basically will have 2 carbon-oxygen double bond. So what we are seeing here is a cyclic anhydride. And for this cyclic anhydride, we are going to call it out, start with what is that dioic acid. So this one is malonic acid. So malonic, and it forms hydride anhydride, so it's a malonic anhydride. And another example, if we have 4 carbon dioic acid, this one is called succinic acid. So when it forms the cyclic anhydride, first of all, 4 carbon plus 1 oxygen, you are going to form 5-member ring, and then next to this carbon oxygen, you are going to have carbon oxygen double bond. So this is succinic anhydride. The next carboxylic acid derivatives naming, we are going to talk about ester. So this is the ester general chemical formula, that on one side we have the R group connect to a carbon-oxygen double bond. So this side, original, is from your acid. So this side is from acid. And the other side is R prime group with oxygen. This is from the alcohol. This is how acid can be made by react carboxylic acid with alcohol through a dehydration to form the new carbon-oxygen bond to form the ester group. Now we are going to learn how to name it. So we are going to use one example. For example, we are going to look at this molecule right here. So for this molecule, the first step is to identify what acid it is come from. So this acid, it will be something like this. So this is called acetic acid. And then we are going to change it to its conjugate base. So when it loses one proton, what's going to happen here is you are going to have the conjugate base, and this conjugate base will be called acetate. Anything and with 8 is the conjugate base of original acid, so acetate, and that will be the root of our naming for the ester. And then we are going to look at what is this group right here. So from the alcohol, this alcohol has an acyl group. So now we are going to put this acyl group kind of like a substitute in the front of the parent chain that we will call it ethyl acetate. So that is how we name it. And the next example, we are going to incorporate some cycloalkyl group. For example, we are going to have this molecule right here. So for this molecule, the first is we are going to identify what is that acid part come from. So this acid part comes from this carboxylic acid, and now we know that this is called cyclohexane carboxylic acid. Now we are going to change it to its conjugate base form. So conjugate base like this. It really does not matter. What we want to know is this conjugate base will be called cyclohexane carboxylate. Okay, the hydrogen got eaten, so it's become 8. So cyclohexane carboxylate. And now the next we are going to look at for the alcohol part, what is our group? So that our group is isopropyl group. So we are going to put it in the front. Isopropyl cyclohexane carboxylate. The next one we are going to talk about here is when you have a cyclic ester. So for cyclic ester, it have a special name called lactone. So any cyclic ester is a lactone. So if you hear lactone, that is just a cyclic ester. For example, if we have a cyclic ester look like this, what we have here is this ester group. Basically, part is inside this ring. So the oxygen that from alcohol is part of the ring. So for this cyclic ester, first it will be called lactone. Then what we are going to do is we are going to tell the audience where that oxygen connects to. The oxygen from alcohol, this oxygen right here, connect to this carbon. We are going to show what is this carbon's position. So as you recall that when we name carboxylic acid, the carbonyl group carbon get the first for the carboxylic acid. So this will be our carbon 1. And then the next one will be 2, 3, 4, and 5. So in this case, the oxygen from alcohol is connected to carbon 5 on this side. So we will call it 5 lactone. So that is the first way we can name it by using the number. The second way we can use here is use the Greek letters. So when the carbon connect to a functional group, this functional group here is acyl group. The first carbon connect to that functional group, we call it alpha position. So this is the alpha position, followed by beta position, and then gamma position and delta position. So the delta position, that carbon is connected to the oxygen that from alcohol. So this lactone also can be called as delta lactone. So that is how we name cyclic ester lactone. So if I say we have a gamma lactone, so what does that mean? You are going to have your alpha position, beta position, and gamma position. In another word, we are going to form a 5 member, right? You will have alpha position, beta, and then gamma, and then after that, you are going to have oxygen, and that gives you a 5 member, right? So this is gamma lactone. The last scenario we're going to talk about here is when you start with a dioic acid. For example, we have our malonic acid. Now, if it forms ester on both sides, how we can call it? So very easy. Still, the acid part is come from malonic acid, so that part will called malonate. Ic acid become 8 because hydrogen got eaten. And then what we have here is from the alcohol side, the R group is ethyl group in this case, so we will have diethyl malonate. So that is how we call this ester that comes from a dioic acid. The last group we are going to talk about here is the amide. That whole general idea is it's come from the original carboxylic acid that either end with ic acid or oic acid, and both cases it will change to amide. So for example, this is our acetic acid. We call it acetic acid. Now we are going to swap this acetic acid to change it to amide. For example, something look like this. So now, because it's amide, so the parent chain here will call acid amide. Okay, so that's showing you that is amide. And then the next thing is we are going to show the audience what is on the nitrogen. So for this case, what nitrogen has is 2 ethyl group, and both are nitrogen. So we are going to indicate instead of numbers, we are just going to indicate it's on the nitrogen. So NN, because you have 2 N, so meaning you have 2 substituent on the N. So diethyl. Show the substituent, and then that will be the naming of this amide. And the next amide we are going to look at here is when the amide is a cyclic amide. So for cyclic amide have a very special name called lactam. Lactam. So you do need to know when you hear the lactam, you need to reflect that is a cyclic amide. For example, this amide we are looking at here. What we have is the cyclic amide. It follows very similar rule as our lactone, that we can number the carbons. The carbon-oxygen double bond carbon get 1 and 2, 3, 4, 5. So we can call it 5 lactam. Or we can use alpha, beta, gamma, and delta. So this also can call delta lactam. So make sure that you know lactam is cyclic amide. So that is the end of this video.